everybody, and welcome back to the PoorMansChemist. In today's video, we are going to be circling back to the chalcogens, and we are going to make some compounds out of selenium. I'm actually going to go for 3 of them. The first one we're going to try is phosphorus triselenide. Now, we know from the last experiment I did with the phosphorus that my phosphorus sucks. We'll give it a shot and we'll see. It's supposed to be a ruby red compound, so that sounds interesting. I mean, we could at least give it a shot. And then I thought what we would do after that is make up some selenocyanates. This one I already tried just to make sure it actually does work. And we are going to, it can be made by combining selenium with fused potassium cyanide. But alkali cyanides are very hard to come by. I don't know. If y'all know where you can buy that shit, put that shit in the comments, seriously, because I'm almost out and I need to re-up here soon. But we can pull off this reaction using potassium ferrocyanide as well. It's not as clean. It does produce some other byproducts, but I think we can make it work. At least enough to where we can look at, the compounds we make, go, yep, there they are, and feel confident that they are what they're supposed to be. So, let's give this a shot, and let's see if we can't make some cool compounds out of selenium. Better be focused, you piece of shit. Okay. Nice if you did something. Okay, there we go. Something's happening. Breathe that shit. Poisonous. Well, that's lame. It was supposed to react with all kinds of incandescence and... Oh, Jesus, God. That smells like death. Yeah, that doesn't smell good at all. But, there it is, man. Phosphorus triselenide. Right there. Pretty damn cool. It was supposed to be ruby red. That doesn't really look ruby red. That looks more like phosphorus red. Okay. Well, that was not really exciting. Like, seriously? Is that it? That's all we're gonna get out of this shit? Man, I got ripped the fuck off when I bought this damn phosphorus. Whoa! Or maybe I didn't. Wow, okay. That was all it took, huh? That little bit. That's what it took to push you over the edge and get you going. Alright. Well, that's it, though. That's phosphorus triselenide. It's supposed to be, anyway. Certainly fuming now, though I have no idea what it's actually putting out. Thank goodness it's a windy day. You explode on me, you piece of shit. I think that's as good as it's gonna get. I really don't want to breathe that, because I just cannot imagine that that is good for you in any way, shape, or form. Phosphides tend to be very poisonous, as does selenium. But, there we have it. It smells almost like natural gas. Well, oh, it's turning orange at the bottom. That's cool. It's not supposed to be orange. Not really sure what's up with that. I'm pretty sure this is phosphorus triselenide. Now I'm not sure. It could be phosphorus monoselenide, or it could be phosphorus pentaselenide. But no matter what, it is some phosphide of selenium, so there you go. That's one. Now, let's see if we can't do selenocyanate. Well, something's happening. There's some kind of reaction, because everything appears to be falling apart in there. Right? Tell him, Roxy. Something going on in there. Well, I don't know. Seems stable enough. Although everything is kind of falling to bits and falling down to the bottom. Yeah. Right, Buzz? Oh well. Alright, the first thing that we need to do for this part of the experiment is we need to make potassium selenocyanate. And so what I'm going to do is I'm going to combine everything in a mortar and pestle and grind it up. We're going to put it in a test tube, and then we're going to heat it up, which will give us the potassium selenocyanate. Will also give us, looks like iron carbide and nitrogen gas. So what I'm going to do is I'm going to take some elemental selenium here. You can see I've got black selenium and red selenium in there, and I'm going to put some of that in here, and some potassium ferrocyanide. See, it's just plain old potassium ferrocyanide, nothing really to write home about. And I'm going to put these in here, grind them up, put it in the test tube, and I'm going to come back when I've reached that part and we're ready to cook that puppy. Okay, actually, because the selenium is very pure, I decided to bust out the good potassium ferrocyanide. Let's see it. It's a bit more nice and crystalline than the other stuff. I've never had any problem working with the other stuff. I have no reason to doubt its purity, but if we're going to do it, let's go all the way. Okay, people, interesting development. Look at this shit. It's already forming the products just as I'm grinding it together here. So, yeah, apparently this reaction is pretty easy to get it to go. Alright, let's put this shit in the tube. And then I need to wash my hands since I've been grinding selenium, and we will be right back. Okay, everybody, I've got the mixture in here, and what I'm going to do now is I am going to heat it up gently. I honestly can't tell if this is just a really intimate mixture of selenium and potassium ferrocyanide, and that's why it looks gray, or if it looks gray because one of the products of the reaction ends up looking gray. But this is how I did it before, and I got it to work. So, I don't know. We'll see. Now, with one of the products being iron carbide, some blackening, I guess, is not to be unexpected. Whoa, that looks weird. Okay, something's happening now. Alright. I wish I knew if this was good or bad. But it's glowing red hot. Of course, with a propane torch on it, that's not really unexpected that it should do that. Oh, wow. Oh, that smells really bad. It should only be giving off nitrogen, but that was a very, very bad smell, like rotten eggs. Really don't want to stand downwind of a fucking angled test tube, though. Or downrange, I should say. Alright, I don't want to go overboard on this. I guess that's just water vapor. But it's heated all the way through. I can see it. I don't know if you guys will be able to see this or not. That's probably not showing up very well. I don't know. I never know with this piece of shit. If I just work under the default assumption that it's fucking up, that's usually good. Alright. I don't want to shatter the test tube here. I don't care if it breaks. I mean, I've got more, but I don't want to lose the product either. I should point out there was no procedure that said to do it this way. I'm just kind of making it up as I go. Don't you fall out of there. Alright, this is the same gray goop that I got before. So, we'll let this settle out, and then we will take the liquid that's in there, we will filter it, and that should contain our potassium selenocyanate. And then we will see if we can't make lead selenocyanate, like I'm pretty sure I did before. And we will also try mercuric selenocyanate, since it's supposed to be green, and all good things in life are green, so why not? Alright everybody, so even with all of that, the really, really fine particulates are making it through. And potassium selenocyanate should not be, I mean, it's very soluble. So, at least based on everything I'm reading, it is. So what I'm going to do is I'm going to, once this is finished filtering, I'm going to centrifuge this solution and see if I can't get that crap out of there so that we can have a nice clear solution to work with. Okay everybody, so here we have the centrifuge solution. That got all that crap out of there. And what I've got here are 4 test tubes where I've put a little portion of that in here. And we're going to try 4 different salts. I was just going to do 2, but since I've ended up with a good bit of it, and I'm not really sure what final form I want to store the rest of this in, I figured I would try these 4 compounds, and we'll see what turns out the best and how I'm going to keep that in my inventory. So, the first one up is barium. I want to see if this will form an insoluble barium salt. So here we go. Barium acetate, and doesn't look like it. That's interesting, because I would have thought that it would. But I may be wrong there. That was just a guess on my part. Now, let's do one that I know should form an insoluble precipitate, lead. Let's try lead acetate, and let's see what that gets us. There we go. That's very nice. So that is lead selenocyanate. It's supposed to be a lemon yellow precipitate, and that looks pretty lemon yellow to me. Next, I wanted to try cesium chloride, since there is supposed to be a cesium selenocyanate that's insoluble, but I don't know if this will work or not. Doesn't look like it. I don't see anything. I don't know, I have to go back and look at that one. Maybe I was wrong about how that one was made up. Alright, and the last one I wanted to try was mercuric selenocyanate. So this is mercuric chloride, and at least I'm really hoping it is. I haven't tested this with anything yet. But this is supposed to form an olive green precipitate. If it's mercuric, it'll be white. Well, alrighty then. This isn't very concentrated. But I don't see anything. Well, shit. I don't know. I don't like it with only one salt precipitating out. I don't like calling that a confirmatory test. Let's go try some other ones just to be sure of what we've got. Alright, so copper selenocyanate is supposed to come out of solution as a brown precipitate, so let's try that. I guess any old one will do. The cesium. Okay, well, there we go. Yeah, that's exactly what it's supposed to be. I guess these other ones are just more soluble than I thought. Oh well, I mean, that's 2. They're both the right colors. So, well, let's see if I can find any more. Alright, I guess we'll try mercuric selenocyanate. So this is mercuric nitrate. Yep, there we go. A white precipitate of mercuric selenocyanate. Ooh, I don't know what's going on with... Oh, it's probably red selenium. Oh, yes, okay, because this is in nitric acid, so it doesn't matter, though. We got our precipitate, which is what we were after. It can turn into red selenium after that. I don't care. Alright, it doesn't look like there are any more that are insoluble that will precipitate out quick and easy like this. So, I guess I'm going to go ahead and end the video there. So, if you liked that video, give it a thumbs up. If you didn't like it, give it a thumbs down. Subscribe, comment, share the video, and until the next one, y'all, I will see you later.